So, November 22nd, 1963. A day that my parents remember very vividly. It's the day at 12:30. The first of 3 shots was fired. Missing the first. The second and third connecting with President John F. Kennedy's assassination. By 12:32 p.m., the President of the United States had been assassinated by who we believe Harvey Oswald. So the Stephen King book, titled that date, November 22nd, 63, was just done as a mini-series, a Hulu original. One of the best shows that I've watched, specifically for a Hulu original series. But it got me thinking a lot about time.
Well, give me like a synopsis of the show. Because I remember seeing and hearing about it. Because James Franco's in it, isn't he?
Yeah,
I fucking love James Franco.
James Franco, true to himself, plays an English professor.
Nice.
Which isn't too far off from
he does that in real life. So.
What James Franco actually is.
Yeah. So I remember seeing commercials for it and finding out it was about time travel with Stephen King and it had James Franco. I was like, I want to see this, but I didn't have Hulu at the time, so I kind of forgot about it, and you reminded me today.
So the summary is it's, at present time, it's 2016. It's 2016. James Franco is a high school English teacher. His life's not that great. He's going through a divorce, whatever. He's sitting down at his favorite diner, and the owner of the diner, Al, leaves for a minute, comes back a few minutes later, and he looks like he's aged years and years. And he's coughing and spitting up blood. And then he finally gives James Franco a secret that back in the closet of his diner is this weird wormhole that brings him back to a specific day early in the year of 1960.
Okay.
Al, the owner of the diner, has been obsessed with the JFK assassination, and with his wormhole has been planning to go back in time and stay there for 3 years to prevent Lee Harvey Oswald from assassinating JFK.
Okay.
That's essentially the premise, and it's harder than just Hitler. You can go back in time and find baby Hitler, and you know that, well, Hitler wasn't a pawn in a CIA cover-up or anything. He was just a fucking bad guy.
Right.
If you went back in time and shot baby Hitler, the course of history would change drastically. Probably eliminating World War II, maybe World War I, and a lot of other events associated with that. Lee Harvey Oswald, conspiracies. No one knows the true story of the assassination. Mm-hmm. Was there one shooter? Was there multiple? Did he make all 3 of those shots from the same window?
Well, yeah, ultimately what just doesn't, like, what was officially said happened, like in the official report, doesn't line up with what a lot of people say they saw and what a lot of people say they see in the video. Mm-hmm. So, there's a lot of room for conspiracy as a result.
But Lee Harvey Oswald was arrested and being brought out of the jail in the basement was murdered himself just days later.
Right. On his way to court or whatever. Yeah.
So, unless the CIA comes forward and admits to it, we'll never know. And this Hulu original does a great job of portraying a different time period, 1960s, showing some of the clips and scenes and music to my mom, who was 13 in 1963.
Okay.
It was spot on. It brought her back to that time period, that age of innocence for her when she was just a young teenager. growing up. The show does that very well, and it also deals with the different controversies in terms of trying to figure out what was actually going on. Going back in time, he doesn't just have to go back and stop Lee Harvey Oswald. He has to go back in time and find out, was it him acting alone, or was he a part of the CIA? Because if you just kill the one assassin, and he was just a pawn, they'll just hire someone else, and it will still go down.
Right.
You could go back in time, murder Lee Harvey Oswald, go forward in time, and you wouldn't have actually changed anything except for the name of the person that was assassinated.
Right. Huh. No, that sounds cool as fuck.
Really cool. And I don't want to spoil too much about it. One of the major things, and this is one idea that I really liked, is how you're able to change things in the past. Like, you can go back in time and carve initials onto a tree, step back through the portal back into 2016. No matter how long you stay, only 2 minutes will pass in the real world.
Oh, really?
But time fights back on major changes. For instance, you're getting closer to discovering something, and time can sense that you're trying to change this one aspect in history, or something that's not known. It knows how everything plays out, and it knows that it doesn't want you getting too close to it. It'll set a fire in your path to prevent you from actually getting there. It'll distract you with visions and hallucinations of other people who have died in your life. Time, if you try to fuck with time, time will fuck with you. It's said multiple times in the show.
Oh, yeah.
But it got me thinking a lot about time travel.
Which is, time in general is something I've always had a problem with.
So if you could go back in time, that's, I guess, the first question that the show raises. If you could go back in time and change one event, if you had a weird wormhole in your parents' basement that only you knew about, and you could just go back and it brought you back to any time that you could choose, what would you go back to?
Okay, are you asking if I would change a major historical event or events in my life?
Either or.
Because there's a whole lot of concerts that I wish I could go back and have seen that I didn't get to see.
And that's not really going back and changing an event, unless you're talking about just altering something in your past that would have allowed you to go see...
Yes.
Like, a concert in 2012 rather than doing...
something else that I did that day. Yeah, exactly. So that, but in terms of history...
That's dangerous, though, messing with your own timeline. Because then suddenly... And here's one of the paradoxes of that time travel. If you successfully change the one thing that you went back in time to change, why would the future you of the past ever go back in time to try to change that?
Because it hasn't happened yet. And isn't that only a paradox because we think time is linear? Like, if time's not linear, then that doesn't really matter, does it?
Yes and no.
Because it's already happened, either way.
It's already happened. If it's not linear, then it already will happen.
Right.
Anything, if time isn't linear, then it preserves itself. You have the paradox of, let's say, it's a Stephen King novel. He sees how well the show did, and he takes his book that he wrote, November 22nd, 63, goes back in time and gives it to the younger Stephen King for him to write that same book. Then you have a piece, and that saves everything in time. But then you have a piece of work that doesn't have an actual origination date. He brought the book from the future back in time to the past to give to his younger self, which was the initial cause of him read in the book that he created. Another example would be, who's the Star Wars guy?
Which one? What do you mean?
George Lucas.
Oh.
If George Lucas now went back in time and gave his younger self the scripts to Star Wars after seeing how well they've done, so the only way that he actually had those scripts was because he was given them by himself.
Right.
It'd be like you meeting your older self right now and saying, here are tickets to a concert this summer. You need to go to this show.
Yeah.
Where do those tickets actually, like...
Well, it wouldn't be that. It would just be going back and making a decision to, I'm going to go to that today instead of that.
But you don't go back into your shoes, generally.
Oh, okay. So I have to go back and interact with myself somehow.
Most time travelers, most ideas of time travel, when you go back, if you're going back to a time period that you also exist in,
I can see myself, yeah.
The other you is still there.
Have I showed you The Jacket?
The Jacket?
The Adrian Brody movie?
No.
Are you serious? Dude, it's a movie about, like, an experiment where a guy's, like, in a mental ward and he's not really supposed to be there, but this doctor starts doing experiments on him and they lock him in, like, a morgue, like a body crate, like, you know, where they keep the dead bodies, the giant freezer thing. They put him in there and then he, like, his consciousness travels back in time into his body.
Well, that's weird.
I haven't shown you that?
So then he's caught up on everything that's going to happen to him.
And, wait. I'm wrong, actually. I'm sorry, I'm wrong. He goes forward in time. I believe he goes forward in time like 20 years or something, or 15 years or something like that. But he's still in his body, but it's forward, not backward. It's like one of my favorite time travel movies of all time. That and Midnight in Paris.
So
you should watch both those.
So he jumps forward in time and doesn't know anything that's happened since he was locked in that little thing till there.
Right.
Yeah.
He just shows up. Like he's like in the crate, he closes his eyes and opens them, and all of a sudden he's outside somewhere 15 years in the future and has to figure it out. Yeah. It's genius. It's a really good movie. But anyway. Okay, so that I just explained that because that's why I was thinking that way. Okay, so I have to go back in time and somehow interact with so that means I would have to
because that makes sense. His consciousness, your conscious mind just being
thrown into the future makes more sense, yeah. There's
different ways that time particles can interact with us.
Yeah.
For instance.
But going back in time, honestly, man, I mean, of course I'd like to, it's hard, it's almost hard to answer that with such limited knowledge, because is time such a powerful force to where even if I were to go back and kill baby Hitler or present any other genocide, that genocide was a big deal enough in time to where somebody else would have risen it up and done it anyway, and you ultimately changed nothing. So if you know, without knowing that factor, sometimes it's kind of hard to pick.
The butterfly effect that you think you'll unravel by changing one instance in history will have drastically different effects that you cannot predict.
Well, that too, yeah.
So, for instance, you go back in time and you kill baby Hitler. Someone else rises up into power. Who is far worse.
Hitler's a dick.
And it's not just World War II. Let's say that it leads to someone else in power who still starts another World War, and they win.
Yeah.
Suddenly you jump back in time.
And things are way worse.
You jump back to the present thinking that you just solved one of history's greatest tragedies.
And it's actually 1,000 times worse.
And you're living in Germany-occupied America.
Yeah. Yeah, see, without, knowing factors on that level, it's hard to pick.
Was never around.
It's hard to pick, where you'd go.
He is Jewish.
So I'm not really sure. What would your answer to that question be?
I don't think that I would try to change anything in history simply because of that.
Without knowing?
It's too hard to predict what you'll mess up in changing.
Yeah.
Now, the 11/22/63, my only complaint with that movie is he did his stuff in the past, came back to the future, and it wasn't what he thought it was going to be. So the portal works in this way where if you go back, you can do whatever you want. History will be altered when you come back through to the present day. But if you go back on again, it'll erase anything that you've done before.
Oh.
That's just the way that time travel worked in this one instance, in this one wormhole.
Okay.
So, for instance, you carve your initials on a tree, you come back in, you can go out to that tree and look at it, but if you go into the wormhole again, you go back to the same exact moment that you went back to the first time, and you can come back through and your initials won't be there unless you recarved them on the second trip.
Okay.
So, he just went back and reset it, because it wasn't quite how he wanted it to be. But, he still changed a lot of other stuff in that period of time, and I feel like having such a power, like, he could have very easily gone back in, reset it, go back in a third time, and then alter it slightly again. You already know what happened to make anything negative happen again. You're slowly unraveling this butterfly effect.
Right. So your problem was that he just kind of like hit the reset button?
Yeah, he just hit the reset button and that was it.
Huh.
And I feel like if I had been in his shoes and I had spent, because you go back, Kennedy's assassinated in November of 1963.
Uh-huh.
You go back to like January or April of 1960.
Oh, so you have to stay there for years?
For 3 years.
Oh,
You don't just travel to a specific time or a specific place. It takes you back to that one date.
And where does it all, so where's his current date? Is it just present time?
2016.
Okay. Wow.
So you're spending 3 years back there. If you just spent 3 years of your life working on this project to stop Kennedy from being assassinated, yeah, sure, you came back and it didn't quite work out. Why are you going to give up at that point?
Yeah. Huh.
Unless you're back home. Literally, time has progressed by 2 minutes in the real world.
Right.
In present time for him. So he goes back to class 3 years older the following day.
Does he look 3 years older?
No, because he's like our.
But
he's supposed to be around our age.
Is that part of the thing though? Like does your physical body?
Yes. Yeah,
age?
By going back in there, you age just like any other time.
Right.
Like Al, the owner of the diner.
So when I come back through, I have still aged 3 years. I did not just age 2 minutes.
No.
Okay.
Yeah, that's correct.
Well, that's kind of lame.
Yeah, super lame.
So where did that, what rabbit hole did that lead you down, this show, then? Like you said, you started doing, like, research and stuff.
All sorts of research on different time travel and different paradoxes and mysteries involving time. It led me down to multiple, and I'm sure that you've seen these, they're all over the internet, the weird mystery reports of
time travelers,
undocumented people that just randomly show up.
Yeah.
And they say that they're from a country that doesn't exist. And they say that their primary languages are things that don't exist, but have a logical conclusion to where we are. And they say,
I haven't heard any, that specifically, but
there's an instance, and I can try to find it on here to get more specific, but there's an instance of one man who randomly just shows up in a German airport and he doesn't have his passport or anything. And his dialect is hard for them to understand. They can't quite pinpoint what language he's speaking. And he tells them that he's speaking, it's a weird crossover between like Spanish and French.
Okay.
And he's from a town that doesn't exist. and he can point to it on a map, and he doesn't understand why it doesn't say his town's name on that map. And it's a little town that exists right in between France and Spain. And then he explains the different countries and how they're working, and it's a logical progression of how Europe could evolve into one larger country.
Okay.
Into the year 2452, or whatever he was from.
So he's from way in the future,
Mm-hmm.
is what he's saying.
A lot of those mystery people have something in common. A lot of them are from the 2040s. So just 20 some odd years from now.
Oh, 2040s?
Yeah,
not 2440s?
No, 2040.
They're saying they're from 20 years from now and Europe's just one nation?
In the 60s. In the 40s, 50s, 60s, and
is when
70s,
this was happening?
Oh, there's multiple reports of random strangers who could be time travelers, who any time that we've talked to one of them, and they've said what time they're from, it's been in the realm of the 2040s. 2040s.
Weird. Because if that's happening in the 50s, 60s, 70s, that means these people aren't finding each other on YouTube and coming up with the same story.
Mm-hmm.
Huh. I've not heard of those specific instances. That's interesting, though.
But so I went down that wormhole for a while, and then I kind of pulled back from the mystery and the paranormal, let's say, and went down to actually researching where we are in terms of time travel, and studying some of the paradoxes and different, because I found it really interesting in that show how time fought back to preserve itself. It was one of the first instances for me watching a movie about time travel where time, it was this fluid thing. It pushed back with its waves, but you could make your way out through it. You could push back and alter something, but it was fighting you all the while. Whereas Marty McFly almost screws his mom and he starts disappearing.
Right.
Time would have erased him.
Right.
Simply because he messed up his parents' relationship.
Right.
Which then would anything have actually changed? Because if he hadn't been born, then he wouldn't have gone back in time.
Nothing would have changed, yeah.
Nothing would have changed.
Well, you sold me. I'm definitely watching this show now.
Here's a thought experiment for you. It's called the twin paradox. And we've talked about this before. Currently we know that time travel, in some essence, is possible. Time is felt differently. Time is relative. Time is felt differently by an astronaut moving very fast in orbit around Earth, farther away from the mass of Earth.
Speed and gravity affect time.
Correct. So, an astronaut who leaves his twin here on Earth and goes up into outer space and stays there for a few years will come back down and be a couple seconds or a couple minutes younger than the brother that he left here. So let's expand that, and let's take a time traveler, a space traveler astronaut, and we're going to zip him at nearly the speed of light away from Earth and come back. Traveling that fast away from mass is going to affect his experience of time. He can come back and see his twin brother has aged 40 years, and yet for him it's only been a couple of days. Both twins can look at each other through a telescope, and they both see the same thing. One twin is getting farther away from the other twin at the same speed that the other one is from him.
Right.
The only difference in that aspect is simply the mass of Earth. But that's negligible. That doesn't have that drastic of an effect.
Just a few seconds, as we know. Yeah.
Yeah. To have a mass-related effect on time, you would have to enter into a black hole or get something dangerously close to an event horizon.
Something with unbelievable mass.
So if both twins, from their perspectives, because I'm the twin on the rocket ship and I'm looking back at you, and from my perspective, you're speeding off that way at basically the speed of light.
Yeah. Assuming you could see it, yeah.
We can watch I can watch you my whole trip, zip away and come back. You can watch me on your whole trip, zip away and come back.
Mm-hmm.
And yet that experience for you lasted years and years. For me, it was just a couple of days. I looked out the window for 2 days and saw you go shooting away and then zooming back towards me.
Yeah.
You watched me do the same thing.
Yeah.
Same speed.
Yeah. It'd be like
So did I go farther from your perspective? No.
What do you mean go farther? Go farther than what?
You are seeing my speed the same way that I see your speed.
Yeah. But it takes you less time and me more. Because I'm not also traveling at the speed of light.
So since speed, or velocity, is a function of time, distance and time, shouldn't that equal? Because it's the same speed, no matter which way you're looking at it. I'm moving just under the speed of light, let's call it 0.9.
The rocket ship is.
The rocket ship is. From my perspective, Earth and you are moving 0.9
away from you.
Away from me in that direction. From your perspective on Earth,
same
the rocket
thing.
ship, so 0.9 over 2 days only adds up to this much distance. But that's all the time that I've experienced. 0.9 over 46 years adds up to so much more distance than my 2 days.
So the problem is in the math. We don't have the exact correct equation to do this, is what it sounds like to me. Because you're right, there's a paradox in the equation, so there's a problem with the equation. Because this is what we see, and for the person on the rocket ship, you're looking at me through the telescope. In that 2 days, it's kind of funny to think about. You're like, what? You'd be literally watching my face get older.
Yeah.
As you go away, old, then really old, really old, really old on your way back.
If I had a powerful enough telescope,
we could see each other's faces. Yeah. Or just a Skype.
But then that instance of time dilation.
Holy shit, dude, hold on.
Causes issues for future time travel.
Think about Skyping.
Yeah.
What if we were to be Skyping during that? That means your phone call only lasted 48 hours. My phone call lasted 40 years. How does that work?
Either I would speed up drastically from your perspective. I don't know how that would work.
No, you wouldn't speed up drastically. That doesn't make any sense.
Why?
It doesn't make any sense for you to be like, hey, how's it going? You know what I mean? Like on fast forward. Because you'd be slower, if anything. But you wouldn't actually be moving slower. I wonder if anybody's ever... Because over that 2 days over the course of 40 years,
so then
I would see you in slow motion and I would be speeding. Right.
Because you're on Earth, I'm on the ship.
Right.
Okay, yeah.
But that doesn't make any sense.
No, it doesn't. And that's impossible until we actually have some quantum entangled Skyping.
Yeah.
Where you can take the two particles that correspond simultaneously.
Well, it's really
light years and light years apart.
It's sending out some kind of communication signal that can travel as fast as light. I don't think we can do that, just sound for now.
The moral of the story, and here's what I'm trying to get at, is the distance that's the issue.
Yeah,
and I think we've talked about this before.
Well, it's a mathematical issue, it sounds like.
We're going at nearly the speed of light, a light year, so almost 40 light years.
Yeah.
Away. In 2 days.
Wait, that wouldn't work. What?
From your perspective, I'm moving at nearly the speed of light. For 40 years. So I'll go about, my total trip is about 40 light years. About 20 light years away and then back. But from my perspective, I do that whole trip in 2 days.
How? You'd have to be moving faster than the speed of light then.
Weird.
What? I don't get it.
Yeah. Now you understand where I'm at.
No, what are you saying though? Like that, what part of the math, where does that come in?
That is the whole issue with the math there. And that's where, this paradox is explained through special relativity. But I don't quite understand it simply because of that. The way that, to someone who's naive to the more intricacies of special relativity, we're looking at it in that way, where from Earth and from the ship, we can watch each other, see that I'm moving a set distance at a set speed away from the planet. We're watching each other get farther away and closer together. But for you, it's 40 years. For me, it's 2 days.
Well, hold on. Where's the 2 days coming from there?
Just throwing out random numbers.
Oh.
It could be 1 day. It could be, you could be 40 years, I could be 20 years.
So this is just, the math here is a problem with explaining faster than light travel.
The math here is the issue in explaining the time dilation difference between the twin that's left on Earth and the twin that's in the ship.
If you could go faster than light.
No. The issue is that I'm not going faster than light, but you can only explain it from one perspective with me going faster than light. From one perspective, from the twin on Earth's perspective, I'm moving just under the speed of light.
Yeah, well, but no matter, like, even just under the speed of light, 40 light years is still going to take you 40 Earth years. Correct. So how could you, in order for it to take less than that, you'd have to be moving faster.
But from the twin's perspective on Earth, let's say that I'm moving at the speed of light. So close to the speed of light that we can, so let's take the astronaut out of the equation for it right now. Just imagine standing here on Earth and watching a ship travel away at basically the speed of light. Takes them 40 years to go away and come back. So they've traveled a total trip of 40 light years.
Round trip would be 80.
No, round trip would be 40.
Well, 40 light years there and 40 light years back.
It's taken them 40 years to leave and come back.
Oh, okay.
So 20 light years there, 20 light years back, right? So we've watched them travel for the past 40 years.
Right.
They come back and they say it's only been 2 days.
But as far as we know with current physics, like, yeah, that's just science. Isn't that just science fiction, though? There's nothing that says that would ever happen. Is there?
Yeah, we've done that. We've measured time to be different very, very minutely just in satellites around Earth.
So you're saying...
Space stations around Earth. The astronauts that are in the International Space Station...
experience time differently.
A clock on there and a clock on the ground tick different speeds.
Right.
Like quantum clocks. That clock, the passage of time up there, is a little bit slower.
Yeah.
The clock down here ticks a little bit faster than the one up there.
Right.
So if you were to leave that clock up there for a couple of lifetimes, it would be off from the clock down on Earth by a very measurable amount.
So
you could set them next to each other back down on Earth, and this would be 15 minutes behind the one on Earth.
So do we know how much less time someone traveling at the speed of light, 40 light years, round trip? It's
not so much about these exact relationship between, is it 20 years to 2 days? Right. Or is it 20 years to 1 year? Is it 20 years to 19 years?
So why
that doesn't matter as much, because it's just a thought experiment. Because the numbers don't matter. We've already proved that this is possible. So let's ramp up the scale.
Okay.
We're just ramping up the scale.
Well, if it were to happen, I would, yeah. If we were to be able to send something, anything, a stopwatch. If we were to send a fucking stopwatch that fast there and back, and it came back having, covered less time, for example, then...
We've already done that.
Well, no, that's what I'm saying is that then
My question with this thought experiment, we've gone over that he leaves from Earth, travels 20 light years away at the speed of light, comes back. From Earth, everyone that's watching this amazing trip unfold, it's been 40 years. Traveling at the speed of light. For the astronaut that comes back and says it's only been 2 days, did he travel 20 light years away in 2 days? If so, was he traveling at the same speed that we perceived him to be traveling at?
Yeah. No, he was not traveling. Yes. What were we perceiving him at? The speed of light?
At the speed of light.
Then yes.
And he perceived us moving away from him at the speed of light. Yes,
he did travel that distance. Just because the math equation doesn't work for it doesn't mean he didn't travel the distance. It means our math is wrong.
So, in 2 days, he traveled 40 light years from his perspective. Which, and from his perspective, from our perspective, it took him 40 years.
Oh yeah, that's right, sorry.
We're on a 1-to-1 scale for the speed of light. Yeah. His scale is drastically altered. Is that purely based on his experience of time?
It's purely based on his experience of time, based on how quickly he was traveling through it.
So is the speed of light faster the closer that you get to the speed of light?
So you're saying the closer you get to the speed of light, does the speed of light then increase?
I'm saying that the speed of light is supposed to be this fundamental constant. Nothing can go faster. It is what it is. Light travels at this speed. If you travel at that speed and can experience less time to go the same distance, you have to be moving faster than that speed. From the astronaut's perspective, he experiences 40 light years of travel in 2 days. Much less than 40 years. So that's much faster than the speed of light. Well, it
based on relativity.
Based on his perspective.
Which is relative. And we know time is relative.
Exactly.
So, where's the issue?
That is the issue. That's the entire issue with the twin paradox.
Which just comes all the way back to it all comes down to just the current understanding that we accept of time. The way we measure it and the way we calculate it is linear. I just don't, there's always been something wrong with that to me. And it's stuff like this right there. This is an example of the math not working. Because there's some piece of the puzzle that...
It's only when you look at it through the framework of special relativity that it makes sense. In that instance, when you take them apart and look at it from the person on Earth's perspective, separate from the astronaut's perspective, that any of it actually adds up.
Or any of what adds up?
Any of the math involved in the situation.
It is relative, so you have to take that into account.
Let's say that you were to hop into a spaceship today, and it could go the speed of light. How long would it take you to go 20 light years?
20 Earth years?
Fair.
There we go. It's the measurement.
Yeah.
It's all about the measurement and how we measure it. So ultimately, here might be a good way to say it is, our understanding of time is just Earth time. It's not understanding, we don't have a good grasp of time as an actual universal law and construct, but we have a grasp on how to measure it and how it kind of works, at least here on Earth. Outside of that, it's hard to speak to anything. There's so much left unknown that we still need to figure out. What if there's a goddamn solar system in a different galaxy, a couple galaxies away, where there's a planet that, because of its molecular structure, time moves differently through that planet than any other planet. Or something, that's completely possible. And it could completely flip everything that we understand about Earth time on its head. It's relative. And as long as we make that distinction between an understanding of how time works as a universal law versus how time works here on Earth, then kind of things become a little bit more clear for me personally to try to understand it as a universal law. It's all the stuff that we add onto it because of our perspective here on Earth where it gets too messy.
Too muddled.
Mm-hmm. Exactly.
Well, let's take a different paradox in question.
Paradox Day. Here on Earth Day. It's Earth Day right now.
Earth paradox.
420 part 2.
The predestination paradox.
Ooh, I like the name of it.
It's also called the causal loop, causality loop, and less frequently the closed loop or closed time loop. It's a paradox that essentially says that if you ever go back in time, that you were already back in time. That the only reason that you went back in time was because you went back in time. Your time travel has already happened.
That's
paradox.
Okay.
In layman's terms, it means that the time traveler is in the past, which means that they were in the past before.
I'm okay with that.
Therefore, their presence is vital to the future. And when you do something that causes the future, when you do something in the past, anything that you do causes the future to be exactly as the future is.
So you can't change the future? In this paradox?
In that paradox, you cannot change the future.
Well, what's the paradox here? Because this just doesn't sound fun. They're just, like... okay, maybe I'm just... Paradox, isn't a paradox where, like, you're trying to explain... These seem more like what-ifs.
They're thought experiments trying to understand the logic behind how time travel works. And when you come in contact with something like a paradox like this one, for instance, or the grandfather paradox, if you go back in time and shoot your grandfather, that creates a paradox. Before your grandparents had your dad, and you shoot your grandfather dead, how can you have actually gone back in time to do that?
Right.
Thus creating a paradox. This is less of an actual paradox and more of a thought experiment on time travel. But because it deals with time and because it eventually falls into this realm of logic or dislogic, they just refer to it as a paradox.
So then, build me a world then. So the situation paradox is you can go back in time, but you can't change anything.
Correct.
That's the only rule?
Essentially, that's the only rule. You can go back in time.
To whenever I want.
And anything that you try to change, you had already done. So it's the year 2018 right now. If you go back to 1978, anything that you do in 1978 has already happened.
And it's already led to exactly the way things are right now.
Precisely. And it would not have led to that had you not gone back in time and done exactly what you are going to do.
That's fun. That's actually fun. Because then...
You are the cause.
If you realize, like, if you go back in time once, and, like, you know, you just... I don't know, you walk into the woods and you discover a time stone and fucking can travel back, discover you can do this thing, and you try it once just to see how it works or whatever, and come back and discover, you basically put that together. Then you could make the decision to go back to whenever, wherever you want and do whatever the fuck you want. Literally. And it's just gonna lead to where you already are.
And then this is where we differ on the whole free will determinism argument. This is an argument for essentially a paradox for determinism. Anything that you will do, that choice that you just referenced making, you're choosing to go back in time and you can choose to do whatever you want. No. Anything that you want to do, you had already done. It's in the past.
Yeah.
You're just going to do it next year.
No, I don't have a problem with that in this instance, because it doesn't...
It's predetermined that you are going to do that.
Yeah.
You could go back in time.
It is that's confirmation of determinism, this scenario.
You could go back in time and punch Hitler in the face just because you wanted to.
Yeah. And
your actions in trying to do that already happened.
Already happened.
Someone already tried to punch Hitler in the face. It was you.
So, and it already led me...
You just filled that in.
No.
For history.
That's the thing. If that's... In this scenario, if that's the way it's working, then this is determinism. That is what it is by definition. No matter what you would have already done, you've already done anyway, because it already happened in time. So it's not just it's extreme determinism. It's time, it's like time's a law determinism.
Futurama, gives a really good example of this and of that, George Lucas going back in time to give himself the script.
Okay.
In one of their episodes, they discover on Fry's ass a binary code that Bender can read off, and it forms a time bubble that you can go back in time and steal ancient artifacts for these aliens that get off on information.
Okay.
They go through a whole bunch of rigmarole. Eventually, Fry goes back in time using that same thing to when he got frozen. Bullshit happens. He comes back to the future, and everything's okay. The tattoo on his ass, after everything's said and done, one Fry is lying dead, one Fry had the tattoo removed. How did the tattoo get on Fry's ass in the first place? Bender rips it off of, one Fry, goes back in time and puts it on Fry before he ever came to the future in the first place. So where did the tattoo actually come from? 'Cause Fry had it on him.
Who actually put the tattoo on him?
Where did the tattoo actually come from?
It came from, yeah.
But he would have never had the tattoo had Bender not gone back in time and put it on.
That's what...
Which led to everything that happened in that closed time loop that resulted in Bender going back in time to put the tattoo on Fry's ass.
Right. No, I get it.
Yeah.
I'm just saying, yeah, that's a good example. That's pretty much exactly what we're saying. Because no matter what, yeah, I could go... If I went back in time and tattooed my own ass, where did that come from then?
Yeah.
Yeah.
If you went back in time...
No, because that's me actually doing it. We don't actually know who did it in the Fry scenario.
Let's say... We do. Bender did.
Well, he didn't draw it, though, on him, did he?
No, he literally ripped the flesh off and
I think I remember
melted it onto the past Fry's ass. So let's say that in your wallet, you had a random business card that you have no idea where it came from. You went back in time, and you snuck into your past self's room, and you put it in your wallet.
Right.
So that's where it came from.
Right.
That's why it was in your wallet, to put it back into your wallet.
But the question is, how did the business card or the tattoo come into existence to begin with, to ever be there?
That's the paradox. In some of those closed time loop scenarios, when you enter into a closed time loop scenario, like the, George Lucas going back.
Where did Star Wars ever come from?
And giving himself the script. He never actually wrote Star Wars.
Right.
He just gave himself what everyone said he already wrote.
Right. So where does it come from is the paradox.
Yeah.
Or
it comes from the future.
It can't come from nowhere, but it doesn't come from anywhere.
Yeah.
That's the issue.
Yeah. That is the issue.
So, but yeah, I mean, the original thought experiment, though, being able to go back and it only works if you realize it while it's happening. If you can put together, so everything that, like, let's say you go back 3 or 4 times and do a couple things, and then you realize, nothing's changing and everything that I did, almost seems to have happened already in some way or another. If you figure it all out, and then go back and just do whatever you want. Because you know that's not a real choice. You're right. It comes back to determinism, because you're not making that choice.
So then those kind of paradoxes differ from what I mentioned before, the grandfather paradox, where...
And go back and kill your own grandfather. How could he have been killed?
You can't change time. By going back in time and altering anything, you alter the initial reason or the purpose of you being back in time, doing anything that alters the past means that you can't be there.
But this is also, we are acting under assumptions here. Like so we're using TV examples, and we have to talk about Doctor Who. In Doctor Who, they mention here, the doctor at one point says, or there's one episode, I can't remember if it's in the first or second season since it started back up in 2005, but one of the doctors, or one of the companions says, if we go back in time and I step on a bug, won't that change everything? And he says something like, no, it's not that, it's not that like fragile or something like that. He's like, time's like a set current. And in order to knock it out of whack, you basically have to build like a dam. He didn't actually say any of that, but that's the impression I got as a fan.
That's very similar to how 11/22/63 presents time. It's a current that's ever moving towards what's already happened.
Right.
And it's very hard to fight that current to stop it from doing things, and it will actively work against you to prevent you from changing. It will find
ways around obstructions.
But in 11/22/63, it literally tries to fuck with the person from the future.
So in a but same to that Doctor Who point, if you go back and you can still do a bunch of things and ultimately have no effect.
Precisely. But
so the grandfather thing.
Or
the idea behind going back and every little thing you do having a drastic effect.
The grandfather paradox is going back in time and killing your grandfather. Or going back in time and killing Hitler. Or going back in time and destroying some information or something, like take the Terminator thing. He goes back in time
to kill John Connor.
Successfully kills John Connor. Why would he have ever gone back in time if John Connor was dead in the future? If you kill your grandfather, you no longer exist. If you go back in time, kill Hitler, stop World War II, and that never happened, all that information that leads up to the rationale that you had to go back in time to murder Hitler
is gone.
So either you exist and go back to present time into a different reality that's totally on a separate time curve from the one that you existed on, and you continue to exist. That's one way of looking at it. Or it's impossible. Or you do the Back to the Future thing, and you hold up a picture of yourself and slowly watch your brothers and your sisters and yourself melt away.
Well, because here's the other part about Doctor Who, though, is like, the idea is you have to really do major things to change major things, but there are these things that are fixed points that can't be changed. Time won't allow it. And if anything tries to happen, then time stops. And at one point, he says the wibbly wobbly thing, where it's a ball. He describes time as like a ball with like imagine like a big bouncy ball with a million mini bouncy balls bouncing around inside of it, kind of a thing. That's time.
There are certain aspects of time that cannot be changed.
Right.
Because those are the fundamental building blocks of the current of time. There are all different theories on time travel that, in Doctor Who's instance, they had to create and choose specific theories related to time travel that made the show work for what they needed to do.
And sometimes they didn't.
And that fluidity of time, being able to go back in time and step on a bug and not have drastic consequences, which literally the beating of a butterfly's wings cause a tsunami across the world. True, things aren't that drastically related. There's plenty of fiction related to time travel where we'll never know until we actually find a way to go back into the past.
Would we? Because what if it is super sensitive? Wouldn't everybody in the future then immediately just, wouldn't it be like, without even realizing it, it's just different? It's like right now 1 + 1 = 2, but like in one set, if someone goes back in time right now and changes something, the next second 1 + 1 = 3, it just does and it always has to us, kind of a thing.
Yeah.
So how would we even know? Like, let's say we send someone back already.
We wouldn't.
Yeah.
The current history of where we are, like, that we know right now, could have been altered many times by time travel.
It could be being constantly altered.
Yeah.
And we still know.
Unless it would send us off on different on different tangents of reality. You have that kind of theory where
it creates an alternate reality.
Precisely.
That
there has been some time travel research which suggests that backwards time machines are possible without any exotic matter.
What do you mean by exotic matter?
Using negative mass matter, for instance, would be one way to create a backwards time machine. You know what negative mass is?
Nope.
It's when you impart a force on it, it acts in the opposite way that any matter that we're used to would. So if you had this lighter here, and I push it to the left, it would actually feel a force coming back at me, coming back the way that I pushed it. The best example and the best way to think about it is, next time you have a balloon, I don't know if you've ever done this science experiment, take a balloon, tie it to your shifter in your car, like a helium balloon, and let it just float there, and accelerate. When you accelerate, you slide back on your seat. Where's the balloon gonna go?
Stay.
Nope, it moves forward.
Oh. Okay, I didn't know that.
So, the balloon is tied to that shifter. It should feel a force pulling it just as you are, pulling it along, and it should react after that force.
Right.
So it should move back and then be pulled forward, but it doesn't. And that's due to pressure differentiations between the air in the front of your car and the air in the back of your car.
Okay.
But that's the way that
it's the same idea.
Negative massed matter works. So if you were to take, for instance, a golf ball or something, and you were to drop it, and it was made out of normal mass, it would fall to the ground and bounce straight back up, right? One with negative mass, it's still affected by gravity in the same exact way. So you let it go, it'll fall down to the ground, but when it hits the ground, it would feel a force acting on it to bounce it right back up, but because negative mass matter feels its force in the opposite direction than where it's actually coming from, it would be pushed down further into the ground.
Huh. Okay. And this exists? This is a thing?
Theorized.
Okay.
It's, one of the alternate theories to dark matter.
Okay. This is one of the things that they think it might be?
Yes.
Okay.
Realistically, in the universe, there's probably so little, negative mass matter that it would be very difficult to gather enough to create a time machine. And the way in which it interacts with normal positive mass matter, because of it feeling normal mass can hit each other and we know how it's going to behave. Equal and opposite reactions. You have two cars that crash into each other. One car is having a force on the car pushing it back. That car's having a force pushing on the car back. We understand that. Negative mass matter, like I said, you drop that golf ball onto the ground. Rather than bouncing back up, it's going to feel more of a force pushing it down. So it's going to bury deeper into the ground.
Right.
And the more that it goes down, the more force of normal mass pushes it up, but it feels that force more down.
Okay.
So what would happen is it would essentially continue to be hit by ground, feel force, and accelerate faster down. It would shoot straight through the planet, out the other side, and be gone forever.
Wow. Okay.
Until it would accelerate to nearly the speed of light just by interacting with normal mass matter.
Okay, so how does this relate to the time travel theory?
So,
research.
That is one way that we could create a time machine, but it would be using exotic matter.
Right, okay.
Without that, we could create a backwards time machine. Essentially, it would be like a donut-shaped object, with a very, very strong gravitational fields inside of the donut.
Mm-hmm.
And by looping in one direction or the other, you can go backwards or forwards in time.
Looping what?
Literally just by walking. Taking a lap inside of the donut.
Wait, I'm lost now.
Take a big donut-shaped object, like a trampoline.
Yeah.
That you can walk around in.
Yeah.
You walk counterclockwise, it takes you back in time. You walk clockwise, it takes you forward in time.
How do they build that? What is that thing?
Simply by creating gravitational fields to form a closed time-like curve. Which we have the technology to do those things, just not on that great of a scale. Because the force required to create such a gravitational field, it would have to be so excessively strong, and manipulating it to the precision that we would need to, not just crush anything that went in there.
Too much.
Mm-hmm.
So that's that's just one, possible...
One thing
they're looking into?
For going backwards in time.
Right.
We know about forward time travel, just not so much a time machine that can take us forward, backwards, wherever we want, like Doctor Who has.
Right.
There's many instances of different proposals for time travel. Stephen Hawking has theorized on speeding around at nearly the speed of light, the event horizon of a black hole. You could spend 5 years doing it, go back to Earth, and they would have experienced 10 years.
Right, yeah.
You can do that same, you can create the same conditions that would have by creating a rotating structure, but any structure that could rotate fast enough to actually have a measurable effect on time would probably be ripped apart by the forces required.
Yeah, there's no mass that can survive that we know of. But there are particles.
And there's light. Which, did we talk about this last time we hung out? Light.
Oh, we can talk about it again.
Light we all know can behave as a particle. It can behave as a wave, with no mass.
Mm-hmm.
Moving at one constant speed. Different ranges in frequencies, are entirely dependent on the energy held within that photon of light.
Mm-hmm.
Now when you pass light through a certain kind of cold gas, the photons pile up with different molecules of the gas, and when they bounce around in there, giving them energy for a while, and when they come out on the other side, they leave their pairs behind and pair up with other photons instead. So we've been able to see light exist as a particle, a wave, and now as a molecule. And the interesting part about this molecule, so it goes in as just photons with no mass, comes out as paired photons of 2 or 3 pairs that are bound together, and suddenly that molecule made up of just 3 photons of light, has mass. Whereas a billion photons of light that are not paired to any other photons have no mass.
That really is a crazy ass discovery.
So they go shooting away at their speed drops, still moving nearly the speed of light, but not quite as fast.
Yeah.
But maybe, just maybe, that is the kind of molecule that we need to be able to build something that can hold together. Because what's better to achieve the speed of light than light itself?
Oh my god. It's a particle that has mass. So we could theoretically build something out of it.
Yes.
Oh.
Eventually, if you gathered up enough of those bonded pairs...
You could make a thing.
You could make a thing. You could fill a jar with it, and that jar would weigh more than just the jar. It would be molecules that have mass that weigh something on Earth. You could put it on a scale and say, yeah, that's 3 pounds of light.
So
you could probably make a lightsaber, yeah.
Not lightsaber, that's not where I was going. Well,
yeah.
Okay, I'm good with that, and I'm happy about that. But what does it take? What would it take to make something a human being could be in and travel in?
Capturing enough of those.
And
probably a few more experiments of figuring out how we can actually work with this material.
Yeah, because
now it's no longer just a wave.
Right.
Or a particle. A massless particle. Most particles have mass.
Right.
That's what's weird about light. It shouldn't be able to behave. It should be a wave.
Yeah.
I can understand it being the only particle with no mass, but now suddenly it does.
Now it does. Also, it does, and it does sometimes.
Yeah, only sometimes.
Only sometimes.
Light behaves differently, either as a wave or as a particle, depending on how you observe it. These molecules, maybe they behave differently when we don't observe them as well.
Well, I heard something recently about that. Damn it, and I'm not going to be able to articulate it properly, but there's a caveat to that. It's not like the popular understanding of that is, so when we're looking at something, it could be literally like something completely different when we're not looking at it. It's not quite that. Like, that sounds very mystical. It's not quite as mystical as it turns out. Like, I can't remember where the hell I saw this either. And I can't remember enough of it. But I do remember recently from a very reputable place. It might have been Joe Rogan or something like that, where they talked about that thing, the light slit experiment, and how it's not as science fiction as it sounds. Basically, it's not as simple as looking at it. It is one thing. When we look away, it's something else, and it's like somehow constantly aware of when it's being observed, kind of a thing. It's not that. It is that, but there's more to it that explains it and makes it not sound so science fiction,
not
like that
so
base explanation. Jumbo. Yeah, like the base explanation I just gave is what you'll see on a lot of TV shows and stuff like that. There's more to it that explain that kind of unravel the mystery and make it make a lot more sense. I just wish I could remember what the fuck it was right now.
I think the main thing, it's not so much about the mysticism of it knows when you're looking at it, but the idea of a lot of these experiments are trying to see light acting as both a wave and a particle at the same time. We can do experiments to prove how light can behave like a wave. We can do experiments to prove how light behaves like a particle, but we can't observe light being both a wave and a particle at the same time. Okay.
That makes more sense.
Yeah.
That makes more sense.
And that's part of the issues with those experiments is,
that's what it was, is whatever I saw it on, it was more down to, it's not necessarily us observing it, but how we're observing it.
Precisely.
Yeah. Our tools just aren't quite right.
The light through the slits, that experiment, it's the way in which we observe it that we are only able to see it as one or the other, not as both at the same time, and that's what we've been looking for. Now seeing it as also a molecule, we have 3 different forms that don't go together in any way at all.
They don't make sense.
No. And when you take the fact that you can round up as many photons as you want singularly, and they'll have no mass whatsoever, and you can have an infinite amount more in just a single pairing, because you take the absence of mass and give it any mass whatsoever, and it's infinitely more massive.
That's interesting. You know what ball lightning is?
No.
People have observed it on planes and things like that, where they can't explain it due to like just atmospheric pressure and stuff like that, but it's literally a ball of lightning and that will just go. And people have seen it. It has shot down like the middle aisleway of airplanes on the inside of an airplane.
That's terrifying.
Yeah. Yeah. Oh. Like people have observed this. This has happened.
Well, I'm not going to flying for a while.
Apparently, we don't have a full understanding of lightning. According to, like, current understanding, we don't know how that much energy is generated in the sky like that to create lightning. I was always under the impression we knew what that was, and it was, you know, hot air and cold air mixing together to create a thunderstorm, and, you know, just like the stuff we learned in elementary school. Mm-hmm. But apparently that's not exactly the case. You don't anything? Because that's like light. So we're looking at an example of an extreme generation of light with power that we don't fully understand.
It's not so much light, but matter, specifically charged electrons.
Okay, in the air, right,
in the
right.
Air.
Yeah, and they make it, yeah. I'm an idiot. That
charge of particles, essentially it builds up charge through the molecules interacting with each other. And when it finds a spot on the ground
to connect
that has,
it's like a tentacle,
an opposite charge.
It's like a charged electron tentacle.
It's constant. It's like static electricity. You can build up a charge, a positive charge in your own body, and then reach out and touch your cat or your dog. And because they have a negative charge or less charge than you can impart that positive charge to them, through them, into the ground.
Well, then why would they say that? So do we have an understanding then of what charges the electrons that much?
I believe so. I'm pretty sure that's just their interactions with each other. That they, oxygen, hydrogen, what's our atmosphere made up of? Hydrogen, oxygen, nitrogen, and whatever else is in it. Specifically H2O molecules that are gaseous, forming storm clouds, have a tendency to build up much the same kind of a static electricity simply by bumping into each other in cloud form. They can pass on and create that charge. It probably has something to do with the Earth's magnetic field, and it interacting on electromagnetic form. Heavier negatively charged particles sink to the bottom of the cloud. When the positive and negative charges grow large enough, a giant spark, lightning, occurs between the two charges within the cloud. This is like a static electric.
Here we go. This is what I was looking for. This is what I was hoping to find. So if you check out the Wikipedia page of lightning and then go to the electrification section, where it's getting its charge, basically, the details of the charging process are still being studied by scientists. So that's probably what they refer. But there's general agreement on some of the basic concepts. Okay. So we have general agreement on certain things, but there are parts of it that's still being looked into, so we don't totally have a total explanation of where the charge is coming from. But we have an understanding. That's interesting. But you're right. I was trying to link that to light when in reality it's electrons, not light. A sin. It's one of the first times someone's phone's gone off during the show.
It wasn't a phone.
Oh, it was an alarm?
Oh.
Still, I just, it doesn't really matter. I always try to keep my phone away from me so I'm not distracted.
Well, I have watches, tablets, and phones that are all synced together. Samsung commercial right here. When you're, hanging out with your Samsung Galaxy Note 8 and your Samsung Galaxy Tab and your Samsung Galaxy Watch, you think a lot about the Galaxy.
Oh.
And your spot within it.
Oh, I see. That's what you do?
Yep, that's what I do.
I have an iPhone.
What do you do with that?
you know.
A phone.
Yeah. I have seen videos online before on YouTube and shit. Kind of, you know, probably fake conspiracy stuff, but of, you know, and of people claiming to be time travelers. Also on the show Coast to Coast AM, they had a time traveler line that was always open for anybody who was a time traveler could call in. A couple times people did. Again, probably, you know, not real, but one can want to believe, can't they?
Oh, this isn't the one that I was looking for. This one I did hear about, though. In the year 2000, a man apparently came back from the year 2038, gave us some information about, 9/11, a couple of wars, and then a civil war that was supposed to happen in, 2008.
Whoops.
Yep. But he came back to specifically get an IBM computer.
Watson?
No, just a specific
model
of IBM computer, because they have, hidden characteristics that are good for debugging other computers. And that's something that we didn't know as a public at the time, and actually know now that these computers are better for that.
Well, that's interesting.
He was supposed to go back to, I think, like the 70s, but he made a pit stop in 2000 and hung out until 2001, and then vanished, and was never heard from again. And this guy he's just one of the random time travelers that, in our lifetimes, has apparently been here from the future. We have no way to know why.
Yeah, but like, who did he talk to? You know what I mean? Like, who's getting these reports?
He, posted on, Coast to Coast AM, a late night radio program. He was just telling the world.
And Coast to Coast AM. The founder of that show passed away on Friday the 13th.
Really?
Not even kidding. Last week. Art Bell.
Michael Phillips.
Fucking love that guy.
Was another
Art Bell.
Time traveler who actually knew the original guy. His name was, Titor. Titor.
Okay.
So Titor was from, 2038.
Titor was from 2038.
Phillips was from, he was born in 2043 and had spent quite a bit of time in 2138. Currently, he lives in 2075. It's probably a little bit later now. Who knows how time travelers actually appreciate what year it currently is.
This is a little bit interesting to me, though. Do you know what the Mandela effect is?
Yeah. I do.
So, basically, it's this idea that we all have memory of things being one way and it turning out that we're all wrong.
Specifically related to thousands and thousands of people believing wholeheartedly that Nelson Mandela, who was arrested during the apartheid, who then became the president of South Africa, rather than becoming the president, he died during the late 80s, early 90s in prison.
And that's kind of where it gets its name, the Mandela effect, from.
Precisely.
So it's something like that. More the examples that the specific example that fucks me up the most to this day is if you Google right now Sex in the City, it's not called Sex in the City. It's Sex in the City. Apparently it was never called Sex in the City. Let me tell you something, man. I have watched shows that have referenced Sex in the City while Sex in the City was still airing, and in those references they say Sex in the City. Find any person in a Joe Rogan Experience, on any old TV show, anything where they ever say those words, they always say Sex in the City. It's never been Sex and the City. I even found a video online of a guy who found some of his, like, girlfriend's old shit, and she had a couple, like a bar of soap, or, you know, a couple things that were officially licensed products, like packaging. This guy definitely, could have faked, sure, but who the fuck is gonna sit there and spend time to fake this shit this good? Like Sex in the City merchandise that says Sex in the City, not in the City.
I'm sure.
Right. There's no question in my mind that show is called Sex in the City. It's never been called Sex and the City.
It's always been Sex and
Absolutely not.
And the City.
I can't explain what's going on, and my theory is that maybe like when they released the movie, it was called Sex and the City, and then it just kind of like changed it all. I don't know.
It's always been.
No, it was not. It's Sex in the City. That's what it's always been. 100%. Without a fathom of a doubt in my mind, that is what it's always been.
So things like Sex and the City, Luke, I am your father, hello, Clarice, which was never said in the actual movie. But I think the Berenstain Bears. But the Clarice, there are some though. Like the Clarice one, I think there's like it was used in a trailer or something like that. Like there are a few. I don't know if that is a specific example of that, but there are a couple examples that people point to as Mandela effect that turn out. It did somehow exist, you know. Or the Luke, I am your father, probably at the time on TV, it was said.
Yep.
Just like that.
Yep.
It's a collective
but also
forgetfulness.
Another one is the Queen song. We Are the Champions.
Yeah.
Everybody remembers, what's the end of the song? How does the song We Are the Champions end?
Well, what
think about We Are the Champions. Come on, how does it end?
No,
like the end of the song, like the last two lines.
I don't know. I can't.
Can't picture it? Everybody always remembers it as We Are the Champions of the World.
Yeah.
No, of the World is not in the song. I swear to God.
Well, where's that from?
I have no idea.
Collective? It's... Collectively, we are bad at remembering things. And when enough people get the idea in their head, it passes through on a cultural level for us to remember things in different ways. A lot of those things can be explained with that.
I don't know.
The Berenstain versus the Berenstain Bears.
That one, I mean, okay, I can accept that some of the things can be explained like that, like that one.
As a kid, it's much easier to understand the name of that bears being a more common spelling of Steve.
It's also easy to misidentify a cursive E and A as a child. So, okay, I'll give you that. Some of them, yeah, probably can be explained that way.
Sex in the City.
It's always been Sex in the City.
I think that's more of a lack of pronunciation.
No, because
on our part.
No, because I'm talking. Dude, like growing up, I spent a lot of time at my grandparents' house in Detroit, and like the only shit they would watch were like the Fox or TBS local Detroit stations that did nothing but play reruns of like Seinfeld and shit like that. Every goddamn commercial break while that show was new. Sex in the City commercials. I can see the logo in my head crystal clear. Like, it's not just like a hearsay thing. Like, I saw it on television. I remember when there was new episodes coming down and they would keep the logo next to the channel's logo on the bottom of the screen. Like, a whole 9 yards. It's always been Sex in the City.
Can you find a VHS?
The one guy in the YouTube video found, I think a VHS was something. But every time I'm at like a used DVD store or whatever, I always look and see if I can find one.
I don't think it's ever been Sex in the City.
It absolutely has been. It absolutely has.
Well, then why would they work so hard to cover it up?
I don't think it's a cover-up.
I
don't think anybody's intentionally hiding anything. Here's where I'm bringing it back right now. Your research on these possible time travelers, they are going back to the 50s, 60s, 70s. This guy is jumping around the 90s and the 80s and the early 2000s. So maybe people are starting to jump back and minor little things are getting fucked with, tweaked. And they're not like big enough to like be erased completely, which is why some of us remember it and some of us don't.
Which is why
we could be seeing examples of what we're talking about, is what I'm saying.
Which is why Nelson Mandela in a
alternate universe
in our history,
or in our history did die in jail.
And that was prevented.
That was the event they came back and changed. Maybe that's the big effect that has caused other minor effects. Who knows?
Because he's alive. It's sex and dead.
Well, no, that doesn't work.
Well, he's dead now, but...
Well, it doesn't work because that show would have started airing after. Like, he would have then not died, like you said, in the late 80s, became president in the early 90s. That show didn't start until long after that.
That makes sense. Because
all that stuff in between is what would have changed.
Yeah, exactly.
Okay.
Because he actually did die in the 80s. Sex in the City did come out.
And then someone came back, saved him, he became president, and it got changed to Sex and the City. Same show got exact same... Think about that. Could be an example. The exact same show got made. They just made it with a different word in the title. That could be... like that
doesn't explain the, 1940s Berenstain Bears.
That's true. That is much older. But what if that was an example of how the effects on time when you do go back and change something? Like, these could very well... I mean, maybe... Like, I'm not... I don't know. I don't know about any of this. This is all just having fun spitballing, but fucking... Like,
it is one of the better arguments for time travel.
Yeah.
And to explain some of the things that have happened.
It's just, I would bet one of my fingers that show was called Sex and the City. Like, I remember seeing the logo on billboards and everything. So, I don't know what's going on there, but something's going on there, is all I'm saying. And I definitely remember here Freddie Mercury going, "Of the world!"
And he just, after they went back in time, he just doesn't say it.
He just doesn't say that part? Or maybe it was added on later in a different version. Because I remember it from the Mighty Ducks.
That's probably why it's remembered that way.
Yeah, the Mighty Ducks. That's where we should go back and watch. Is watch the Mighty Ducks. I think it was D3.
Literally in some other form. And that's the way that a lot of these things develop. Like the "Hello, Clarice, I am your father." "Luke, I am your father."
What part of that's fake again? Explain that one.
"No, I am your father."
Oh yeah, he never says Luke.
Mm-hmm.
Right. And then is the whole "Hello, Clarice" never said?
Never said in the actual movie. I don't think it's said in a trailer either.
Might not be. I was just using that as an example earlier.
But you, what? Does he says something like "good morning" or "good evening"? So, something not like the...
He does, and he does say Clarice a bunch of times eventually.
Clarice. But those things are picked up by popular culture. And in order to get the movie reference across, they bring in everything that you need to know to make the connection. Rather than saying, "No, I am your father." Well, what the fuck was that? "Luke, I am your father," makes a lot more, brings it into a better context to be able to say, "Luke, okay, Star Wars, we're on the same track." "Hello, Clarice," you bring in another character's name, and suddenly you're able to relate it back to the movie much faster in those scenes.
And it's even hard especially with stuff like Star Wars, to be able to point at that and use it as an example, because from the time of the original trilogy's release to now, there's been how many different cuts and versions that have come out with scenes missing and added and changed, and so especially with that one, it's hard to point at it as a real example of what could
that's
be
just
this thing.
That, and I believe that and the "Hello, Clarice" are perfect examples of how culturally we just remember those lines incorrectly.
Yeah, I could see that. Just
because of the way that we've adapted to referencing those scenes or those movies, we've remembered it and put it into our memories that it actually happened that way where it didn't.
Right.
Much like the Berenstain Bears, as a child, it's much easier for us to read the name Steen than Stain. Because that's a very uncommon... Berenstain is already an uncommon surname, let alone Berenstain.
You know what is interesting about that one, though, is that when it was a TV show. Because you feel like you remember the person on TV pronouncing it Berenstain. Today on the Berenstain Bears.
On the Berenstain Bears.
Yeah.
Ish. And then when you get into Sex and the City,
No.
And the City. Sex and the City.
Sex in the City.
Sex in the City.
Sex in.
Sex in the City.
Sex in the City.
Sex in the City.
But I remember seeing the logo. That's the issue. Like, the logo doesn't look right now.
Your memories are not to be trusted.
I'm not saying that's incorrect. I'm not
and my
disagreeing.
mom were in a horrible car accident when I was very little. We were on vacation, coming back from somewhere, and I know for a fact that it was foggy, and that's why the truck didn't see my mom's car. It hit us and we went spinning off into the distance. It wasn't foggy.
Okay, but guess what? I didn't suffer a traumatic experience that I could have also suffered a head injury. That's extreme. Like, that's a traumatic...
We weren't injured.
So what? So what? You were little in a car accident. You were scared as shit.
I remember it. I remember...
That can affect
the
memory.
Conversation specifically with the other driver. Like, I'm 6 years old. I remember talking to the other driver. I remember talking to the police officer. I remember him asking me questions.
I'm talking, though, this is on the same like from my perspective at the point in time where I was seeing this was the same time that I was watching on a regular basis Seinfeld. It was when I was younger. It was one of my favorite shows.
Especially Seinfeld.
Yeah, exactly. Like, if someone tomorrow would be like, "No, it's Steinfeld," like, or Seinfeld or something like that. No, that's incorrect. It's Seinfeld. It's always been. This is the same exact thing. It's always been Sex in the City, and now all of a sudden it's Sex and the City.
Sex in the City.
In the.
Yeah, and the.
No, I see what you're doing.
I'm saying exactly what you're saying.
I'm
Sex in the City.
I'm just saying I agree. I think some of it's cultural memory things. Some of it's not.
I have no way to explain how thousands and thousands of people believed that Nelson Mandela was...
That's a real weird one. Like, to think he was the fucking like, I never... That's what threw me out, because when I started looking into this stuff, like, a while ago, whenever I first heard the words Mandela effect, a bunch of the main things I found were, like, the Sex and the City of Berenstain Bears, and then I found a video that talked about the Nelson Mandela thing, and it struck me as weird because I always remembered him as president. I never remember him dying, personally. Do you remember him dying?
No.
No. Okay. And we were alive. We would have been alive. We would have remembered... Well, we would... It would have been taught to us in school.
They remembered him dying in the 80s.
We were taught that he was president in school.
Mm-hmm.
So...
The memory is for adults, though. In the 80s, going into the 90s, it was a shock to them to learn down the road that this man who was dead is actually president.
Yeah, that's really bizarre.
And then it turned into a lot of people thought that it was a cover-up or some sort of conspiracy because they swore that they remembered hearing that this man who battled for equality in a nation that was oddly behind the U.S. in giving equality to people, that was on the news because it was coming right out of a period of time in the U.S., like decades after the U.S. was beginning to make a lot of the same choices to end segregation and vote for more equality. It was leading into the time period of the Rodney King issues.
Yeah.
Right before that, we're on a very similar pace. Everything that was going on in the apartheid movement in South Africa was being broadcast here because we were interested in it. It was culturally relevant to us as well.
Right.
And that's why so many people
remember a news story
remember him dying and being shook or being
affected
by his death.
Yeah, that's a really weird one. I got nothing for that.
It'd be like finding out in 1969 that you actually just lived through 2 terms of JFK and thinking that he was assassinated in 63.
Or like tomorrow Michael Jackson releases his new album.
That'd fuck me up.
That would be real fucked up. Like, yeah. That's bizarre. That's very, very bizarre. There's just something going on, is what I'm saying. I don't know what all this is, but it's something.
Nelson Mandela could be explained by news of another South African movement leader dying, and because the name Mandela wasn't so widely known at the time, it just got blended together with, it's like not really knowing who MLK is and hearing that Malcolm X died. And being like, I have a dream guy died.
Yeah. I don't know. That's a weird one. Something to think about. Well, we're pretty fucking deep here. If you want to wrap this up, this is a lot longer than I expected.
Yeah, I think it's about dinner time.
Alright. We didn't even get to one of the main things I wanted to talk about, so we'll have to do another one sometime this week. But,
tomorrow.
Yeah, alright. Alright. Fucking, there's no real ending to this. I kind of usually just end it, so.
This has been Coast to Coast AM with Burton and Jordan. Thank you for listening, folks, and we'll be back to you next time.
Enjoy it?
Yep, that was good.
Alright. Hope you enjoyed.